Okay, 16.1 homework, solving exponential equations. Now, obviously we've talked about before how you do these graphically, and sometimes you've got to adjust some things. I'm going to show you how to do this algebraically, and then I'm going to kind of walk you through real quick some things you would need to do if you think about it graphically, on the calculator. So algebraically, you just want to get x by itself, okay? So the first thing you've got to do is you've got to get rid of this 1/4. So this is times. So to get rid of it, you multiply by 4 or divide by 1/4, however you want to think of it. So I'm going to do it as multiply. So when you do that, you got 5, 6x equals. Now, you're going to do this. You can use your calculator to multiply and simplify. So if you simplify, after you multiply that, you're going to get 25 over 36. Now, the key is here, you want to get the same base of 5 and 6, okay? So what is 25? 25 is really 5 squared. What is 36? 36 is really 6 squared. So really what happens is this becomes 5 over 6 to the x equals 5 over 6, all of that being squared, okay, our exponents here. So what is x? X is 2. Now, that only works if you can get these as the same base. If you can't, then you got to do it graphically. Now, let's talk about with the calculator itself. What you want to do is, let's go back and think about the function, okay? So this is less than 1, so that means it's going to be decreasing. This is a vertical compression. That means it's going to flatten it out, okay? So what does that mean in terms of our window? If we're thinking about it graphically, just a second. So here I go. It's a function that is decreasing and is going to flatten out at 0. Now, why is that important? Because when I want to set up my window, I need to think about some things. So x min, okay, x min, you can still probably do -10 to 10. That's going to be okay. But my y min, okay, first of all, I want it equal to this number right here, which is a really, really small number, okay? It's less than 1. So if I'm thinking about my graph, I want y min to be 0 and my y max to just be 1, because that number that I've got it equal to here, that 75 over 432, that is between 0 and 1. Okay, now what do? I set in my y1 and y2. Here's my y1. That's my 1/4 times 5 over 6 to the x. And my y2 is my 75 over 432, which would be a horizontal line. And then I just go to second, trace, number 5, intersect, press enter 3 times, and I'll get it at 2. So I should get x equals 2. Now remember, it's going to say x equals 2. What's the y going to be equal to? The y is going to be equal to what I set it to, which is that fraction, which would be some big, ridiculous decimal number. Okay, so let's go to the next problem, problem number 17. There is a drought, and the oak tree population is decreasing at the rate of 7% per year. Okay, so we did a problem about the laser beam decreasing by 1%, and we subtracted that from 1. Same concept. 7% is 0.07. We're going to subtract that from 1. So it's actually 93% that's hanging on each year. That's how it loses 7%. That's our R, or our B. That's our common ratio. If the population continues to decrease at this same rate, how long will it take for the population to be half of what it is? Now, it doesn't give us a starting population, so here's all we need to do. Let's say we start with a population of 1. Okay, so that's our 0 term. So it becomes 1 times our common ratio, 0.93, to the x equals what? What are we wanting to set it equal to? To be half. So we set it equal to be half. There are our two functions. Again, just go on the calculator, put those two in, go to second intersect. Again, you want to set your y to be between 0 and 1, okay? And if you do that, you're going to get approximately 9.55. So a standard window from 0 or negative 10 to 10 on your x would work in this case. It's going to be close, but it'll work. You'll find where the intersection is. Okay, sometimes, again, though, think about the terms of word problems. Since it is a word problem, you could actually set your x-min to be 0 because you can't have negative time. So again, always thinking about context of problems to help you. Just utilize the calculator here to help you solve. Okay, let's look at one more problem. Let's look at problem 21. Tim is considering different savings account plans that pay 1%. So if they're paying 1%, that means it's increasing. But this time it is compounded monthly. Okay, so in the previous problem, they didn't compound it monthly. When interest is compounded monthly, the pays interest every month instead of every year. The function, so they give us a function for interest. P is the principal amount or initial deposit in the account. R is the interest rate. N is the number of times, blah, blah, blah. How many years will it take Tim to earn $200 at this bank should he switch? Okay, so what we have to do, we have to go back to the original problem, which said we had $5,000 to invest. Okay, so we have $5,000 to invest. So what we're going to do is we're just going to take this equation and put that in. So P is the $5,000 he started with. Parentheses, 1 plus our interest rate, okay? So it's compounded, it's 1%, okay? But we put 0.01, that's our R, okay? So this is our R. Over N, now if you go back up in here, N is the number of times, it's right here. N is number of times, the interest is compounded per year. Well, if it's a month, then N would be 12 because there are 12 months in a year. So that becomes 12 times N, which again is 12, to the T, which is what we're looking for, how long it would take. And it wants to know how long it would take to earn $200, okay? So we don't set this equal to 200. What we actually do is we need to set this equal to 5,200, because if he started out with 5,000 and he wants to earn $200, that's how much he would have now. So those become our two equations. Now, in this case, again, T or X here is time. So you want your X-min on your calculator to be 0. X-max, I have no idea how long it's going to take, okay? But just to expound our time frame, I would probably go to like 20. Make Y-min be, I'm wanting it equal here. So I might do Y-min as 5,000 and do Y-max as, let's say, 5,500. That way that 5,200's in there in the middle. Graph it, go to second intersect, and when you do that on the calculator, you should get as a solution approximately 3.92 years.